Hello, everyone. Good morning. Dear authors and invited guests, welcome to the technical session 8E. Myself, Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held the day before yesterday in Pune, India, and the virtual event is being held through Zoom yesterday and today. It is 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we will have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. Please note that on the 7th minute, I will be raising a reminder. There is another request to all the participants that you please stay connected to us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for our session, Dr. Vishwajit Thakur. Dr. Vishwajit Thakur is a professor at Indrashil University, Mahesana, India. He has authored and co-authored research papers in national and international journals. He has published 3 books. His areas of specialization are digital logic design, computer organization, image processing, robotics and control. Welcome to the session, sir. Sir, would you like to say anything before we start with the presentations?
I request,
There is some problem with the mic, I guess, sir.
yeah,
No
start.
issues. Yes, sir. We'll start with the presentations. I would like to call upon our first presenter for the session, Nagesh S, presenting the paper on the title Analysis and Classifications of Water Quality using Machine Learning Techniques. If you're available with us, I request you to kindly take over with your presentation, please.
Yeah, hello, Praj.
Hello. Yes, sir. You can start presenting. Yes.
My screen visible?
Yes, sir. It is visible now.
Hello, everyone. This is Nagesh from Vidyavardhaka College of Engineering, Mysuru. And on behalf of my team members, Manohar, Abhishek, and Sumit, I'm going to present the analysis and classification of water quality using machine learning technique. First of all, these are the contents. Uh, the context and purpose of this project is water is an inevitable resource and it has got serious significance. And as we all know, water is the universal solvent. It is capable of dissolving both physical as well as chemical parameters. So this paper focuses on evaluating the water quality using machine learning and water quality index for classification of the water quality. And access to safe drinking water is a global concern, and evaluating the water quality is a critical issue for agricultural industrial users. And this initiative was developed to develop the tool which we can use to analyze and classify the water quality based on various physical and chemical parameters. And abstract of this topic is that water quality monitoring is the critical for public health and environmental sustainability. Conventional methods like mathematical calculations are usually time consuming and require specialized skills, whereas the machine learning is usually fast and scalable solution for classifying water quality. Few of the key parameters that we are going to use are pH, turbidity, organic carbon, and other contaminants. We will explore that in the next slides. Machine learning, such as random forest and support vectors, are used here. And this paper tries to enhance the precision of water quality using various machine learning techniques and to provide a real-time, cost-effective, accessible solution for diverse environment. And as we all know, water should be portable in the sense drinkable, And if it is not drinkable, it might cause issues like typhoid, cholera, hepatitis, which may cause dehydration and other complications. So traditional methods rely on sampling and chemical testing, but usually they are time consuming. So it's better we go for a machine learning approach to analyze large data sets and automate the water quality detections. Algorithms like random forest and SVMs are usually better to be classify the models, and this aims to develop a model which classifies the water as potable or non-potable. And it is, if it is non-potable, then we can classify the water for various purposes like agriculture, industrial, and other domestic purposes. And we go for training the data using various data sets and identify the pattern and use that for classifying the water in the future. So these are the two things we are considering: physical and chemical parameters. Few of them are mentioned here. Temperature, electrical conductivity, turbidity come under physical parameters, whereas acidity, pH, alkalinity, other toxic substances come in the chemical range. In this project, we are considering only 9 parameters, which includes both physical as well as chemical parameters. As we can observe in the graph, pH, hardness, solids, chloramines, sulfates, conductivity, organic carbons, trihalomethanes, and turbidity. And these are the examples for safe and unsafe water. In safe water, you can observe that the pH is around 7, so it would be a safe water, and other parameters are in the optimal range. And in unsafe water, you can observe it is 3.71, which is acidic in nature, so it would be unsafe for drinking. And then here are the few literature surveys we done. Uh, First one was a review on data mining techniques for prediction of water quality by Priya Singh and Pankaj Deep Kaur. This reviews on various models and evaluation methods like pre-processing, data evaluation, and all. And result of this was the water quality not only depends on physical and chemical parameters, it also depends on the environmental factors like climate, humidity, etc. So what second one was water quality prediction using machine learning by H. Amir and H. Nasolai. They used ANN and SVM for the prediction of the water quality. And the conclusion was given as SVM is more suitable for prediction of quality rather than ANN. And another was IoT-based quality machine that was by Pandey and Koditala, and they present structured minimal effort framework for continuous checking of water. They use IoT-based system, and the outcome was the high recurrence and high portable low control system. And the last one was water monitoring system for real-time water quality by Kumar M and Shah RK. It includes smart water quality and quantity meters, which concluded that high pH increases the viscosity of water and also make it them toxic. Our proposed system involves software implementation. We are especially focusing on software part of the project. So we collect the data set from various sources like Kaggle website or other websites, and we undergo various processes like data pre-processing, which involves normalization and removal of null data using various imputation methods like random and median imputation. Median imputation is nothing but calculating the median in the entire column and replacing the null values with it. Random imputation is nothing but we find the lower and upper limit and generate a random number between that and replace the null values. Next, data visualization includes heat maps and other parameters to visualize the null data, whether it is present or not. Then model implementation using support vector and random forest. As you all know, support vector divides the points into two parts, and a successful part will be considered and failure part will be considered for negative results. And random forest constructs the various decision tree, as we all know, and it considers only a decision tree which produces a best optimal solution. Next, example is to optimize post-processing techniques and condition check. We will check for the condition whether the water is potable or not. If it is potable, then we will display it to the user that water is potable. And if it is not drinkable, then we will go for validation where we classify the water on the basis of water quality and we display it to the user. As we all know, the flow follows uses SVM and random forest, and it uses the various parameters we are using are solids, hardness, chloramine, pH, conductivity, surface, organic carbon, tray halometers, and turbidity, main parameters. And all models are trained for the prediction process. And after the training process, it would be easier, and without human intervention, we can predict the water quality. Data set is required, and it is classified as testing and training data, and training are used and testing is used for model performance calculations. And then here are the various workflow of our project. First is data pre-processing, which involves normalizing missing values with median and random imputation methods. And feature selection involves water quality measurements and scaling the columns so that there won't be a higher weight to the particular column. Splitting data set
Excuse
involves
me, sir.
splitting.
Sir, we have crossed the 7-minute mark. I request you to kindly conclude your presentation as soon as possible.
Yeah, sure. Yeah, computation of water quality, we use some formula that is weighted arithmetic index. It was first proposed by Horton. And then learning algorithms, we use support vector as well as random forest algorithm. We classify the numeric data into discrete to increase the accuracy by using this table. And you can observe this table, 0 to 25 is excellent, drinking for industrial irrigation. And results are for random forest, we observed 0.91 accuracy and support vector it is 0.86. And gradient boosting underwent before overfitting, which caused the issue. So we consider only random forest and support vector. And limitations is water quality varies on the climate also. And model performance issues, models might go under fitting or overfitting scenario. And prediction reliability, maintaining reliability is a difficulty, and calibration is also. And conclusion, water quality, we use M2M model, that is machine to machine. That is in the front end we use sensors and all, and back end we use models machine. And the scalable intelligence solution holds promise for sustainable water management and environmental monitoring. Thank you.
All right. You tell, are you using long-term, short-term memory?
Sure.
Long-term, short-term memory.
Long term, short term.
Long-term and short-term memory, are you not using?
Uh, Usually this works on the basis of runtime and it does not store any data. But in the future, we are planning to use a cloud storage to store the predicted results so that we can increase the data set and utilize that in the future.
The water कहाँ से लाए हो? From where do you use the water? Which water do you use?
Usually, currently, we are focusing on the software implementation, but in the future, we can collect various the water from various sources like lakes, rivers, and other contaminated waters. The exhaust from the filter we use in our day-to-day life. We can utilize those waters and use the various sensors in order to detect the various water quality parameters.
All right, thank you.
Yeah.
Thank you so much for presentation, sir. Now we'll call up the next presenter. Request you to kindly stop presenting. Our next presenter is Hriday Aditya Dharmala, presenting their paper on the title Contextual Visual Question Answering on Remote Sensing Images. If you're available with us, I request you to kindly take over with your presentation, please.
Yeah.
Okay.
Hi, good morning, everyone. Just give me a second. I'm setting up. Can someone confirm me if my screen is visible?
Yes, sir, it is visible now.
Yeah, thank you. So I'll begin. Good morning, everyone. Today I'll be presenting our work on contextual visual question answering for remote sensing images. I'm Hriday Aditya, And this research was conducted at Vasavi College of Engineering under the guidance of Dr. K. Ramohan Rao. So let's start by understanding the fundamentals. Remote sensing involves capturing Earth imagery using satellite and aerial sensors. While this technology generates massive amount of data, the challenge lies in extracting meaningful information from these images. Visual question answering, or VQA, is an AI system that aims to bridge this gap by allowing natural language interactions with our images. Our focus is specifically on applying VQA to remote sensing imagery. The current challenge in remote sensing image analysis are threefold. First, we face a severe limitation in annotated datasets. Second, traditional models require enormous computational resources. And third, the existing methods often struggle with specialized domains like remote sensing. Our goal is to develop an efficient, domain-specific VQA system that leverages an open source architecture, a mixture of expert architecture known as Prismer, and help along with a Mistral 7B language model to address these challenges. We'll talk about this further as we go. So let's go over some of the existing methodologies. Previous approaches relied heavily on a combinations of CNN and RNN models as shown in this diagram. This process involved three main steps, as you can see: a main feature extraction using a ResNet-like architecture, and the fusion of vision and language models using the vision language features, and final prediction is the last step. While this approach showed promise, it had limitations in handling complex queries and required significant computational resources. And furthermore, the existing methods face several key limitations, such as the CNN-RN model suffers from dependency on predefined answer sets and vanishing gradient problem. Additionally, vision transformer models generally struggle with complex database issues and often require extensive human annotation. So I'll cover our methodology overview. So looking at our overflow diagram, you can see there are 5 key stages in our system. We begin with the data acquisition from UGS dataset, followed by our automated pre-processing stage, the model training phase, then followed by the model training phase where we integrate our custom segmentation model with the open source Prisma model. And later on from this, the description is generated, and this allows description thus generated is done by multiple mixture of expert models, which include segmentation model as discussed, OCR model, and in-depth estimation model. Finally, we have a question answering module which uses a fine-tuned Mistral 7B to generate natural language responses based on these descriptions. So let's talk a bit more into our data processing pipeline. So our data pipeline consists of 3 main components. First, for data acquisition, we use high-resolution RGB images from USGS HRO dataset. There's an example given on the screen, which provides diverse coverage of urban areas, forests, and water bodies. In pre-processing, we developed an automated system to generate segmentation masks from 4 major classes, mainly agriculture, water, roads, and buildings. Finally, our training process for our segmentation model utilizes UNet for feature extraction. And later on, for the question answering part, we fine-tune Mistral 7B for generating contextual responses using the framework known as LoRa, which is low rank adaptation, and using Unsloth, which is one of the major frameworks software open source tool, which is available to fine-tune our models. As you can see on the given slide, the Prisma architecture is also given, which allows us to combine multiple modules such as object detection, segmentation, depth, to combine all of those and give a proper description. So in more detail, we use a 2-stage approach. First, the UNet model segments the satellite images into classes like water, buildings, etc. So there are no manual labels needed anymore. Second, we fine-tune Mistral 7B, a language model, using QLoRa for efficiency, as I mentioned before. And this combines visual analysis with natural language reasoning. As you can see, this is our evaluation report. So evaluation metrics show a significant improvement over our baseline models. Looking at the Hamming distance, we achieved a value of 3.1 compared to baseline 3.4. Remember, lower is better, because as you can see, the Hamming distance measures the misclassification errors here. And our F1 score is about 0.782 and a match ratio is 18.4%. Both represent meaningful improvements over the previous approaches, which is the state-of-the-art approaches available at the time of this paper, known as prompt RSVQA. So these metrics demonstrate our effectiveness of our domain-specific adaptation. So let's look at some practical examples here. Here we compare a system's output with a baseline Prisma output. Notice how our model provides more detailed, contextually relevant descriptions. For example, you can see here it also the model, the unfine-tuned, the normal model gives an answer like it's an aerial view of a tennis court, which is a hallucination example. Whereas our model, which with the proposed changes, it gives a rich contextual description, as you can see on your slide. And another example here, this example showcases that the model is not able to not only identify bridge, but also describe its surrounding environment infrastructure. It is also able to demonstrate better spatial understanding here. So it is able to understand there's a bit of trees present here. So this slide showcases a system's ability to understand context across different types of landscape, from urban environments to rural settings. The model can accurately identify and describe various elements while maintaining contextual relevance. So this image descriptions go beyond simple object recognition. They go to provide meaningful insights about the scene composition. So here we demonstrate our system's ability to engage in natural language. So you can see that from the generated description, we can ask any question to the user, or any question to the machine, and we get the answer back in a natural language format through the Q&A, Mistral Q&A, which we developed. And you can also see the graph on the right side shows our Hamming distance, how our Hamming distance varies with number of questions, indicating consistent performance even with increasing complexities. So the applications of this technology are far-reaching, from urban planning and disaster management to environmental monitoring. Looking ahead, we see opportunities for expanding this model's geographic coverage, integrating real-time data feed, and adding multilingual support, and also adding much more smarter Q&A bots like reasoning bots, which are very famous, such as DeepSeek's one, which are very famous right now. So to conclude, we developed a more efficient and accurate approach to remote sensing VQA, combining domain-specific expertise with state-of-the-art language models. Our results show improved accuracy while requiring fewer computational resources, and this is paving the way for more accessible Earth observation tools. Thank you. And thank you for your attention. I'm happy to take any questions you have.
So what is the major application?
I'm sorry, but I'm getting an echo. Can you please repeat it?
What is the application?
What is application? So basically, this is useful for answering multiple questions for government website people. They can query how much of land is actually urban, how much percentage of land is urbanized, how much of agricultural land is left. They can get an easy estimate of the given piece of land image, and they can have the estimate ready with their hands. This is one of the few examples, but the examples are much more widespread to whatever we need. Like we can also count the number of buildings present in a given image. We can also count, like we can give a much more accurate descriptions of a given image like that. And for object detection for military purposes, etc., they can be also being used.
Okay, thank you.
Thank you.
Thank you so much for your presentation. Now we'll call upon the next presenter for the session. Our next presenter is Afruja Akhtar, presenting her title on a paper on the title Cryptocurrency Price Prediction and Security Challenges in Machine Learning Approach. If you are available with us, I request you to kindly take over with your presentation, please. Afruja Akhtar, if you're available, I request you to kindly take over with the presentation, please.
Unmute. Assalamualaikum, ma'am. Thank you so much for giving us this opportunity. Good morning, everyone. I am Afrojak sir from Dhaka, Bangladesh.
We may request all to mute the mic. Mute the-
Ma'am, are you presenting any slides?
Yes, ma'am. I will present. Can you visible?
No, ma'am, it is not visible up till now.
Give me 5 minutes.
For sure, what we'll do, we'll come to you at the end. We'll take up the next presenter. Meanwhile,
Okay.
no
Thank
issue.
you so much.
Please rectify your errors. We'll get on to the next presenter.
Okay, thank you so much. Yes, presenter.
Our next presenter is Harsha S. Khurana, presenting on paper titled Deep Learning Based Stress Detection Using Facial Expressions, Recognition and the Affinite Data Set. If you are available with us, I request you to kindly take over with your presentation, please. Ms. Harsha S. Khurana, if you're available with us, I request you to kindly take over with your presentation, please.
Yes, ma'am.
Okay,
Am
ma'am.
I audible?
You are audible, ma'am. Yeah.
Yes, ma'am. Okay. Uh, is my screen is visible?
Yes, your screen is visible now.
Good morning, one and all present here. Myself, Harsha Khurana from Vanita Vishram Women's University, Surat. It's my privilege to be a part of this 9th International Conference, SMARTCOM 2025. So moving ahead, the title of my work is a deep learning based stress detection using facial expression recognition and affectnet dataset. In this paper presentation, I'm going to cover the introduction, literature review, problem statement, objective, methodology, dataset analysis and description, result and discussion, and last is conclusion. So in the introduction part, as we all know, stress is a major health concern that significantly affects the mental state and can have an adverse effect on physical well-being if prolonged. So early detection of the stress is can helpful and prevent the health-related issues. Am I right? So individual stress pattern can be detected using various biosignals technologies like thermal, electrical, and so many ways. But as per the WHO, there are 1 in 4 people suffer from stress and the mental health conditions. So there are so many causes of stress. It could be a work-related stress. It could be a relationship stress, family-related issues. There are so many areas you will feel the stress in our daily life, right? So as per the literature review, we have found that there are some non-intrusive systems was developed by analyzing the driver's facial expressions to detect their emotional stress and to save the driver for driving to get rid of the accidents and all. And as per the literature review, we have found the anger and disgust are the 2 negative emotions that employ the stress among the human beings. And we have also find one data set like Fabo data set, which is used to recognize the human emotions by combining the informations from different sources like facial expression, speech, body language, body movements, and so on. And there are so many ways like through videos, we can extract the facial images and eye movements, eyebrows positions, and with the help of it, we can detect the stress. Now, the problem is the traditional method of detecting of stress like self-reporting psychological tests are very time consuming and do not educately give the correct result. So we can suggest like the non-intrusive techniques such as analyzing the facial expression captured in the real life scenarios offers a promising alternative to detect the stress and the non-stress stress. As you can see the faces on my slide. Now, the objective of the objective of this research work is, as it is well said, face is a mirror of mind. So one can observe the one's emotion or the mental states on one's face by examining and analyzing the facial expression. So we have can classify the facial expression as a stress and the non-stress stress. The primary goal of this research is to improve the pre-trained model for to detect the stress through the facial expression. The proposed approach involves training the deep learning model using a data set to recognize the subtle changes in the facial expressions through correlated work, detect accuracy for the stress detection for the pre-trained model on changing the parameters, and by using the AffectNet dataset could be used for the stress detection. So the methodology I have used to categorize the stress, this research work uses a AffectNet data sets, and which uses a facial, in this data set, we have a facial expressions categorized into 8 different emotions, and considered a few of the emotions categorized as a stress, and few of the emotions we have categorized as a non-stress. And this work also expresses the various machine learning pre-trained models like inception, exception, mobilenet v2, vg99, and efficient combination network with AffectNet datasets, and compared the efficiency of all the models. So for testing of the models, we have collected the live data to verify the trained models able to classify the stress or non-stress test of an individual or not. So for testing, videos and images of an individual captured during the interview, as we know that when the people are facing some interview or some challenges, the face of that particular person is in stressed, right? So we have captured the videos, and then we have converted that videos into the images, and the images are saved into the name in the named folder of that particular individual persons, and we have tested that images. So as we know, during the work, we have analyzed one data set, which is the AffectNet data set, in it having a 4 million photos, which is manually labeled with the 8 distinct emotions like happy, natural, neutral, angry, sad, surprise, fear, and contempt. So AffectNet is one of the biggest collection of facial expressions, and the data sets also includes the annotations for violence and arousal, which are essential for understanding the intensity and the nature of emotion. One such valuable data set is AffectNet, and this is the summary of the AffectNet data set which is used in this work. In it having a 4,40,000 images, which is queried from different, which has been collected from the various search engines using a different queries, and emotions are there. And we have used in it, the labels are used is neutral, happy, anger, sad, surprise, disgust, and intensity of violence and arousal. These are the summary of AffectNet data sets, and these are the few images of the AffectNet data sets that classifies that emotions of the facial expressions. And for the same thing, we have used the Adam optimizer, which is used to, due to its efficiency, we have found the optimal solution. And after doing a parameter changes, we have found the exception, and the MobileNet V2 model gives more accuracy apart from the other models, and which is able to classify the expressions into a stress and the non-stress, or which are able to detect the face in a stress or the non-stress state or not. So for the testing of the data or to verify the model against the invisible images, dataset models are tested on a data collection of an individual during the interview scenario. And according to the model, our proposed model based on AffectNet dataset shows the accurate result for the stress classification, as you can see in these pictures. Now, the conclusion is the research work has a potential to provide a non-intrusive solution for the stress monitoring. That means this research work is completely based on a non-intrusive solution, not intrusive, and which can be integrated into various applications like a workness, wellness program, mental health assessment, personal health monitoring system, and so many more. And the results show that the model trained on AffectNet datasets could classify the images as stressed images accurately based on the emotions of an individual. And as per the experiment, two models gives the more accuracy on changing the image size or other parameters for the stress detections. So this is from my side. Thank you. Any queries?
What method have you used for deep learning?
So we have used some pre-trained models like MobileNet, V2 exception and all for classification.
Okay, thank you.
Thank you, sir.
Thank you for your presentation, ma'am. Now
Thank
we'll
you.
call upon the next presenter.
Ma'am, I am ready to present my presentation.
Uh,
Akhtar.
okay. Sir, could I take Ms. Arfuja Akhtar for the presentation?
Okay, ma'am.
Just a second. Just a second.
Okay.
Are you fine? Now I'd like to present to you all Ms. Arfuja Akhtar presenting her paper on the title Cryptocurrency Price, Production and Security Challenges in Machine Learning Approach. Now you could start with your presentation. I'll stop my sharing.
Ma'am, can you visible and hear me?
Yes, ma'am, the presentation is visible and we can hear you.
Okay. Thank you so much, ma'am, for giving us this opportunity. Good morning, everyone. I am Afroz Akhtar from Dhaka, Bangladesh. My presentation topic title is Cryptocurrency Price Prediction and Secret Challenges in Machine Learning Approach. Now I am starting my presentation. This is my content. Our slide carries this section. Before going ahead, let's know what actually cryptocurrency is. Cryptocurrency is a digital wallet. It can be used as asset, transaction, buy or sell it online. It is used as money, but only digitally. It is transacted or traded in online. So it is important to know the prices of cryptocurrency. As we know, cryptocurrency prices are very unpredictable, which makes it hard for investors to make decisions. Traditional methods don't work well for forecasting with such unpredictability. Is our model good at finding prices for this time series data? Let's see. This is our object. These are simples. Predict the price, future prices of cryptocurrency despite their high volatility. To demonstrate how blockchain technology can enhance security and privacy in financial systems, to design and evaluate a hybrid deep learning model for predicting the price for 5 major cryptocurrencies. This is my introduction. Machine learning, especially models like LSTM and GRU, is great for analyzing data and predicting outcomes in time series data. Machine learning allows predictive insights by analyzing data without manual programming. For our research, we choose hybrid LSTM GRU models because they combine the long-term memory capabilities of LSTM with the efficiency of GRU. We also explore blockchain technology ensuring secure and decentralized transaction tracking. However, blockchain systems are unsafe for attacks like double spending, brute force, and fin attacks. We studied and proposed some solutions like zero rings, zero knowledge proofs, ring signatures, and hardware wallets like hot and cold wallets to counter these challenges. Literature review. We reviewed past studies and approaches in cryptocurrency price prediction and blockchain security. We analyzed some papers who evaluate with the same matrices as ours. This helped to build our model and refine our methodology. We didn't get any paper with more than 4 currency that we overcome and work for 5 cryptocurrencies. Our methodology revolves around developing a hybrid LSTM GRU model. This block diagram represents our proposed hybrid LSTM GRU model. We propose the We process the data set by splitting and normalizing it. Then we use a hybrid LSTM GRU model with a dense output layer. After training and evaluating the model, we predict future prices based on the trained data. This is the data collection table. Where we gathered historical data for 5 cryptocurrencies: Bitcoin, Ethereum, Binance Coin, Litecoin, and Ripple. We have explored many websites for collecting the data. Among them, we collected dataset from Yahoo Finance and Kaggle. The dataset was splitting into 3 sections. First, 70% data we used for training, then 15% for validation, and then the last 15% data we used for testing to ensure a balanced evaluation of the model. This is the architecture and workflow of our model. We constructed the model architecture and workflow for proposed model. For the architecture demonstrates how LSTM and GRU layers are combined. From the architecture, we can see that the input entered into the first LSTM layer with 128 unit of GRU, and then 128 unit after that the second LSTM layer with 64 unit layer. Here the workflow of our model starts with dataset uploading and preprocessing. We apply data splitting, sliding windows mechanism. Then the proposed data feed in LSTM GRU model. We use the dense layer as the output layer of our model. The workflow includes model training, model evaluating, and at last predicting stages. By using our models, we have done the experimentation. The graphs illustrate the effectiveness of our prediction model, with the red lines representing the actual prices and the blue line representing the predicted prices. This graph shows the performance of each cryptocurrency with minimal error in most cases. As observed, the prediction closely follow the actual values, which highlighting our model's successfulness. Here we present detailed tables comparing actual cryptocurrency prices with the model's predicted price generated by our model. We have forecast for upcoming 5 cryptocurrencies. And then the result analysis. We evaluate our model by calculating some matrices like mean square error, root mean square error, mean average error, mean average percentage error. The evaluation matrices of our model demonstrate its effectiveness in predicting cryptocurrency prices. We have given root mean square error and mean average percentage value in this table. As we had seen before, some papers matrices in literature review by comparing with their mean average percentage value, we observe that our model gave MAP value less than 5 of all 5 currencies, which indicates that our model is performing better than others. Our result shows that the hybrid LSTM GRU model is effective. We can see that this decreased model loss graph during training and testing phases shows consistency, which is critical for a genuine prediction system. These results validate the authenticity of our hybrid approach in capturing complex price dynamics. Then conclusion. In summary, our research demonstrates that cryptocurrencies powered by blockchain offers fast, low cost, and secure transactions. Our model successfully predicts prices, which is very close to the actual price. Blockchain is secure, but it still needs stronger privacy protections. Then future work. In the future, we plan to optimize the model's hyperparameters and explore quantum mechanism machine learning for advanced prediction. We also aim to integrate economic data and blockchain metrics for more comprehensive insights and focus on improving privacy in blockchain technology to make our model even more robust against cyber threats. Thank you for your time and attention. I love to answer the questions if you have.
How much is the
can't share you.
What is the machine learning time in your research? How much time it takes
Sir,
for
please repeat the
computation?
question.
How much time it takes to compute the output? I hope you get the
Sir, I
question.
can't hear.
Sir is
Sir, repeat
asking,
the question, please.
Ms. Arfuja, sir is asking how much
You,
time it takes to compute the
how much time does
Four,
it
4 to 5 minutes, sir.
take? Okay,
4 or 5 minutes.
okay.
Okay,
Thank you
thank
so
you so
much,
much
sir.
for presenting. Now we'll go on to the next presenter.
Okay, thank you, ma'am.
Thank you. Our next presenter is Rinkesh N. Parmar, presenting on the title Enhancing Automated Cotton Disease Detection Using CNNS for Sustainable Agriculture. If you're available with us, I request you to kindly take over with your presentation, please, sir.
Good morning, everyone. I'm Rinkesh Parmar. Today, I will present our research on enhancing automated cotton disease detection using CNN for sustainable agriculture. So basically, this automated approach for detecting cotton disease using deep learning and our work that aims to help farmers that improve the crop health and yield with an efficient and accurate disease detection system. So here my presentation outline that is the introduction, research objectives, literature review, methodology, result and discussions, feature work, conclusion and references. So we start with the introduction. So basically, the cotton is the one of the most important crop worldwide that providing raw material for the textile industry and supporting millions of farmers. However, diseases such as the circus spora, powdery mildew, and cotton mealybug that significantly impact yield that leading to the economic losses. So that challenges with the traditional methods that the manual inspection is the very time consuming, labor intensive, and prone to the errors. After that, delayed this. Delayed detection that leads to the several crop damages. And our solution that we have developed a deep learning based automated system for early disease detection that we can use CNNs to classify cotton diseases accurately. And our research objective that's developed an automated CNN-based system for early detections and that real-time disease monitoring, early intervention to minimize crop damages, that improve efficiency in cotton disease management practices, that safeguarding crop health and boosting the productivity for farmers worldwide. So there are the literature review. So in first, deep learning revolution, Sky introduced CNNs with the ImageNet at enabling the large-scale images recognitions, and Lee et al. That proposed the visual reporting for a semi-supervised learning that useful for a limited label data. After the second that is found that is a CNN-based approach for cotton disease detections. The foundations of modern image classification was led by Crisby et al. In 2012, who introduced CNN train on ImageNet, and this breakout through the enabling models to the learn uh, that learn detection. After that, in transfer learning for improved accuracy. We use the VGC16 that achieve an 98.6 accuracy, and after that JITL 2020 that applied ResNet and VGG models that enhancing performance with the minimal training data. And recent advancements are that is the uh, GNNs for data augmentations, and after that, attention mechanism for better feature restrictions, and there are hybrid models for temporal sequence learning. So that methodology that we use a data set and pre-processing that are we use the 10,000 to 48 images of cotton plant that categorize into 12 different classes, diseased and healthy. There are sources from agriculture, farm, research station, and diverse geographical region that we split our data set into 80% that is for training and 20 that is for validation, that is for balanced representation. After that, we use the data pre-processing technique that an image size that all the images are resized into 224 pixel by 224 pixels, and then we have put the next technique that is the normalization. After that, we use use the data augmentation techniques for different data augmentation techniques that uses rotations, flipping, shifting, contract normalizations. After that, our model architecture that we developed a different model architecture. First, that is the baseline CLM that input in baseline CLM that are input layer that accept the images of a size. After that, convolutional plus next calling layer that extract the features and reduce the dimension. After that, at ResNet 50 that uses the residual connections for better training. After that, advanced architecture that are ResNet 50, DesNet 121, Inception V3, hybrid CNN, LSTM that combines the special feature extraction using the CNN with the temporal and sequential dependencies. That is LSTM. After that, in the training and evolutions, we have used optimize the ADAM and loss function that is the categorical cross entropy, and where bet size that is a 32 and epochs that is 15. And in we use also use early stopping method that stop training if no improvements in tan epochs. After that, in evolution matrices there are accuracy, conclusion matrix, precision, recall, F1. Right, next, there is the ROC curve that is for receiver operating characteristics, then AUC that is for area under the curve. That is the fine tuning for improved performance. After that, in the next methodology, after that, resultant discussions are there. The CNN model achieves the high accuracy for predicting thick cotton diseases. That accuracy ranges is for 90.5 to 95%. That best performance that had we found that healthy that is achieved 95 accuracy that followed by the circus spora 94% and powdery mildew that is 93.8 performance. After that, here you can see the performance metric comparison. That is table one. We said that hybrid CNN STM achieved a high accuracy that is 94.5. In the key improvements, that is data augmentation that's helped prevent auto fitting and the precision recall and FN score that high values that is 89.8 percentage to 94.5 that indicate the low false positives. After that, in recall, that is a high recall that is 89.2 percentage and 94 percent that ensure the most disease plants are detected. So here you can see the disease specific analysis that affect insects that achieved 93 percentage and 92 percentage, and you can see the accuracy and F1 score that is from different disease categories over here. That is armyworm insect, bacterial blight, cotton millibug, and cull virus. After that, here you can see the before and after comparison. We use the baseline CNN, DesNet 121, ResNet 50 for applied all the CNN architecture to the different diseases. After that, we have found the hybrid CNN LSTM that achieved a high accuracy over the baseline CNN, DesNet 121, and ResNet 50. So a hybrid LN LSTM outperform from the other models, and it is generalized achieved across the different cotton growing regions. So here you can see the my result discussion that found powdery mildew disease. It is a fungal disease that affect a wide range of plant that including cucumbers, squares, roses, and grapes. So here there is a healthy plants that easily found that my plant is healthy. After that, in result displays, also we found region generalizations that cooperates the region-specific data to improve the adaptability to climate and soil variations that effective for across cotton growing region that ensuring the accurate prediction that we can find easily accurate results from the if we cooperate with the region specific data. After that, in model enhancement, data augmentations improve the training diversity that drop out the regularization that reduce the overfitting that are after balanced evolution that metrics like F1 score, ROC, AUC that ensure a comprehensive evaluation. After that, in agriculture application, that real-time disease detection that support early invention, lightweight model, also enhance the accessibility for farmers. After that, our future work that aims at the data set explains that include temporal, seasonal, and regional data to enhance the generalizations and adaptability. After that, next that is the hyperparameters optimization, that fine-tuning learning rate, batch size, architectures to boost performance with the automated methods like grid search. But after that, we use the IoT integrated integrations for real-time monitoring via mobile devices. We use the GAN, that is the generative adversarial networks, to generate a synthetic image to improving models robustness. With these advancements, our models can be deployed in the smart agriculture for real-world disease detections and crop management. So our conclusion, that is a hybrid CNN LSTM achieved the highest accuracy, that is 94.5 percentage, and F1 score is, that is 93.3%. There are various models like DenseNet 121, Inception Method also perform well, but were outperformed by the hybrid model that reliability in detecting diseases such as circus spora, powdery mildews, and cotton mealybug, that is suitable for real-time agriculture application due to the high precision and recall. And we use the future or enhancement like IoT and synthetic data that can further improve accuracy and accessibility. Thank you for your time, and I am happy to take any question. Thank you so much, sir.
How does CNN work? How does CNN work?
Sir, CNN work with the different the data set pre-processing techniques. We use resizing, normalization, data augmentation techniques, that is rotation, flipping, shifting, contrast adjustments. After that, CNN architecture, we different types of batch size images we perform. There are 32 batch size, that every size, all the images are in circulate with the different pixel values.
Okay, thank you.
Okay, thank you so much, sir.
Thank you for your presentation, sir. Now we'll be going to the next presenter.
Okay, can I left, ma'am?
No, sir, I request you to kindly stay with us if possible.
Okay, okay.
Yes. Thank you.
Okay, thank you, ma'am.
Our next presenter is Owen A. Tolentino, presenting on paper on the title Forecasting Electricity Consumption Using ARIMA Model. If you are available with us, I request you to kindly take over with your presentation, please.
Hello, ma'am. Good morning. Am I audible?
Yes, they are audible. You can start presenting also.
Okay, ma'am. Let me allow to present my screen. It's already presented, ma'am.
Yes, sir. Now it is visible, sir.
Okay, ma'am. Thank you. So, thank you for giving me a chance for presenting my paper at SMARTCOM 2025. It is a pleasure to present to you my research paper entitled Forecasting Electricity Consumption Using ARIMA Model. I'm currently affiliated with Tarlac Agricultural University, Philippines, which is under it is the College of Engineering and Technology. So let me start with my presentation. So actually, all of those things, all of those appliances that we have already used in our daily lives is dependent on electricity. So one of the key practices or things that we need to consider on creating this kind of resources, we need to utilize these resources carefully. These things are very important so that these things have alternative on creating these sources of energy. First is we have what we call the energy harvesting on our country, which is similar to you, that we are using some natural resources such as the solar energy and the windmills. However, this electricity might have shortage in some time. So in order for us in order for us to mitigate these things, we need to have these three things to be considered. First is the monitoring, next is forecasting, and mitigation. Forecasting allows us, or monitoring allows us to check and monitor on what are the behavior of a certain data or demand from the electricity, and while forecasting is the process of predicting on what will be the demand in the near future. Given these two tools, we can mitigate on what are the problems that may arises in time, and prior to happening, we can think of what are the solutions that we can do because of this tool of monitoring and forecasting. So there are a lot of forecasting models or forecasting algorithm that I have search. And on literature, we have what we call the auto-regressive integrated moving average, linear model, or Holt linear model, and exponential smoothing. However, ARIMA, based on the nature of the data set that I've already collected, it shows that ARIMA model is the most fitted algorithm to be used on forecasting the electricity consumption. So here is my operational framework. I have four steps on prior to prior to generating the result. The first is the data gathering. Next is data preparation, prediction or forecasting, and afterwards we will be continuing with what we call the clustering. So the data set for the actual forecasting is dependent on the data provided by the Department of Energy Philippines, wherein it provided a data from year 2006 to 2016, and this is the basis of the data for forecasting. The data being provided did not needed for sophisticated pre-processing technique, because they just provided me a text file for the or CSV file for the forecasting, and they have provided one column data with multiple rows, considering the date, considering the years and months, and the current consumption for each month. So the RIMA model stands for autoregressive integrative moving average, wherein autoregressive refers to the model that shows a changing variable that regress on its own lag or prior values, while integrated represents the differencing of raw observation to allow the time series to become stationary. So it can be considered as it would be a time series. So moving average incorporates the dependencies between a observation and a residual error from moving average model applied to log observation. Given the data set provided by Department of Energy, we have already I supplied those data to a specific algorithm, which is ARIMA, and it provides me possible models and combinations of ARIMA in order for me to forecast the data. Considering the BAC and AAC, we can see that if it has a lower BAC or AIC, we can consider it as a good model. However, upon creating the forecast, I also considered what we call the MAP, or mean average percentage error. And the lower the MAP, the higher the accuracy of forecasting. Although ARIMA, the fourth ARIMA is not that low in AIC and BAC. It turns out that it is more reliable for us to base on MAPE rather than on the AIC and BAC. After creating the forecast, clustering is done so that we can identify on what are the things that we need to consider on what we call consumption of a certain month. So here we can identify on which month of the year where demands of the electricity is high and low. So after creating the clustering, after using or supplying the data on clustering with k-means, it shows these observations. So you can see that we are on the right side, on the month and year, we can see what are the peaks and lows of what we call the consumption, and then at the same time we can see the silhouette index, which refers that the silhouette index close to 1 indicates that the data being clustered is acceptable. So actually there are a lot of clustering number of clusters that I've checked, but the summary of the silhouette for each of the clusters retains with just 3 cluster with a good clustering silhouette score. So in my conclusion, with the support of the Department of Energy Philippines, several ARIMA models were tested to achieve precise prediction, and ARIMA 111011 emerged as the most accurate model due to its lowest AAC value. This indicates that model capability to deliver reliable forecasts. The prediction revealed that the electricity consumption in 2017 would increase by 18.99 with a 2% MAP, signifying a moderate error rate. Further analysis identified three distinct clusters of consumption: high, medium, and low. The clusters process validated by silhouette score close to 1 confirms the reliability of the categorization. These insights provide stakeholders with a clear understanding of electricity consumption trends, enabling them to strategize effectively in addressing demand of fluctuation. So it means the actual goal of the study were to provide the actual stakeholders and decision makers on what would be their decisions on supported with the forecasted data being provided. So that's all. Thank you. So if you have any questions, I'm ready to answer your questions. Thank you.
What are the other models?
The other model that I have observed is we have what the Holt model, linear exponential model. Then actually there is another model for ARIMA. It's SARIMA, and there are a lot of models. But on the part of the ARIMA, we have already created more model in a sense that we investigate in the different parameters that are suitable on forecasting the data.
Okay.
Thank you, sir.
Thank you so much for your presentation. You can stop sharing. We'll take up the next participant for the presentation. Our next presenter is Manmeet Borkar, presenting the paper on the title Machine Learning Driven Non-Invasive Biomarker Measurements. If you are available with us, I request you to kindly come ahead with your presentation, sir.
Yeah, hello, am I visible and audible?
Yes, right now you're
Yeah,
visible.
hello. Good morning, everyone. I'll be presenting my work on the machine learning driven non-invasive biomarker measurement. So, just one second. How do I get the slides to change? I'm sorry, I'm having an issue with that.
You can just tap on that. You can press enter. It will change.
Oh yeah, you can see the change slide, right?
Yes, sir, we can see it.
Yeah. So what exactly is a biomarker? So a biomarker is any parameter which measures or indicates the metabolic state of the body, and it is critical for early diagnosis and health management. So for example, your blood SpO2 levels or your hemoglobin levels, these are all biomarkers. So what are the challenges that we are facing? The conventional methods are invasive, costly, and inconvenient. A lot of people have certain phobias. You have a phobia for needles or hemophobia, the fear of blood. So this can be an issue for such people. And it's also quite costly and invasive. And secondly, in rural areas, there's an issue with healthcare access. So they are expensive, as well as not a lot of people have access to such healthcare. So the objective of this research project was to develop a non-invasive, cost-effective machine learning-based biomarker measurement system. So the problem statement was that there is a rising prevalence of diabetes, cardiovascular diseases, and even hyperuricemia in rural areas, according to a recent epidemiological survey. And therefore, there is a need for regular health monitoring, affordable and accessible diagnostic solutions, as well as they should be quite user-friendly so that people can use them even in remote areas. So the proposed solution provides a non-invasive measurement of three biomarkers, that is blood sugar, total cholesterol levels, and uric acid. And the key components for this system is the MAX 30102 sensor, which is used for data collection, then the machine learning models for the biomarker prediction, and a graphical user interface for interaction. So over here, you can see that the sensor which was selected was the MAX 30102 sensor. There were many reasons for selecting the sensor. It's compact, accurate, affordable. And another thing was that it has, as you can see there, it has two LEDs. One is the red LED and one is the IR LED. The the interaction of the infrared LED, infrared light with the blood biomarkers has been studied before, but I also wanted to see if the red light has any interaction with these with blood biochemistry. Secondly, there was the calibration, which was to mitigate the effects of ambient light and the variability in the readings. So what we did was we used a pulse oximeter case we enclosed the sensor in the pulse oximeter case, and this basically served two purposes. Firstly, it ensured that there was no interference from ambient light. And secondly, when you place your finger and it's enclosed, it will ensure that the readings are stable. And thirdly, the data collection part. It was a diverse demographic which we tested. It was the age range was around 13 to 78 years, and the health status also varied quite a bit. And then the data which was collected non-invasively was correlated with the lab results. So here comes the machine learning approach. We had 4 features of importance which were selected. We named them red, infrared, and the derived metrics such as RB and IR. So when you place your finger within the module and the light which is reflected from your finger is captured by the photodetector, there will be a digital value which positively correlates with the amount of light which is captured. That is termed as red, R. Similarly, for the amount of infrared light which is detected is infrared, IR. Now, when the finger is not placed, when let's say the system is idling, let us call that a basal value. And when the finger is placed, that is the red value. So from red, if you subtract the idle value, that will be your derived metric of RB. And similarly, you have IR. And as you can see from this algorithm which we ran, we found that RB, IR, and IRB were the most important features for prediction of these biomarkers. We tested a lot of machine learning algorithms actually, linear regression, KNN, decision tree, RF, and SVR as well. And based on the selected features, which we had 4 features, 72 data sets were developed, each having a different combination of selected features. So this is just one example of how a data set looked. So this has all 4 features, R, RB, IR, and IRB, and the target for blood sugar. Similarly, there was maybe another blood data set which only maybe had R, RB, and IR, but no IR. This was done for all 3 of them. So these 72 data sets were split in across 3 biomarkers. And here's the performance evaluation. Basically, the 72 data sets were compared for all of the 5 previously mentioned algorithms, and they were compared based on the mean square error. And finally, the selected algorithm for the selected data set yielded these results. So for uric acid, we used linear regression, which had a coefficient of determination of 0.87 around. For total cholesterol, we used random forest, again, coefficient of determination of around 0.87. And for blood sugar, we use KNN with a very high coefficient of determination of 0.959. And based on the predictions, we realized that the average prediction offset was around less than 10% compared to the lab results. Now, if you go to buy a glucometer in the market, you will have a certain ISO standard which they have to meet. And it basically says that if your let's say blood sugar level is below 100 milligrams per deciliter, then if I test my blood sugar 100 times, 95 times out of those 100 times, there should be an offset of less than 15%. Therefore, we can see that these results are well within those standards. And here was the graphical user interface. So now we input the sensor data, which we have collected from the sensor, that is the MAX 30102 sensor. We have RB, IRB, IR, and R. And the outputs are the predicted biomarkers, total cholesterol, uric acid, and blood sugar. All 3 are actually predicted independently, as there are 3 different inputs for them, as well as 3 different models which are being used. So in this particular case, as you can see, the blood sugar for this particular individual was around 130. The predicted was 126-ish. Total cholesterol was 171 as per lab reports. We predicted it to be around 163.26 milligrams per deciliter. And for uric acid, the lab reports said it was 6.4 milligrams per deciliter, and we predicted it to be around 6.08. Currently, a lot of work has already gone into it, but there are certain improvements that we can look into. Firstly, the first two are advanced signal processing as well as dynamic calibration. The main aim for both of these would be to ensure that any environmental factors such as ambient light or maybe even skin tone, as we are basically, this is a non-invasive way of basically you're interacting with the blood biochemistry in a non-invasive manner, and therefore even the skin tone can affect the amount of light which is maybe absorbed and reflected. Therefore, maybe some dynamic calibrations or some advanced signal processing can help mitigate those issues. Secondly, the standardized placement, a better ergonomic design could result in even more stable readings, improving the system overall. And comprehensive testing. We actually split our data collection into two parts actually. First was the non-invasive data was collected prior to the blood being drawn, and the second was the non-invasive data was collected after the blood being drawn, basically to see if physiological stress has any issue, has any correlation on the blood biomarkers, which we did find. And therefore, we had a slightly smaller data set if we had only used the data set where blood was drawn after the non-invasive data collection. So we are looking to have a bigger data set. And in conclusion, we were able to create a more accessible and affordable non-invasive health monitoring solution, which can help in improved early detection and health outcomes. The significance is that it addresses rural healthcare challenges, as this is there are no running costs associated with it. For example, if you go to buy a glucometer, you will have to invest in the Lancets, which is a running cost. And secondly, it did demonstrate feasibility with promising results. It had a less than 10% average offset for all three biomarkers across all the validation. Yeah, that's about it. Thank you for your attention. And if there are any questions, I'll be more than happy to answer them.
Good presentation.
Thank you, sir. Should I stop, sir?
Fine, thank you.
Yeah, thank you, sir.
Thank you so much for your presentation. Now we'll call upon the next participant. Kritika P, presenting a paper titled Mapping Social Barriers in Indian Plantation Communities, Insights and Recommendations. If you're available with us, I request you to kindly take over with your presentation, please.
Thank you, ma'am.
Thank you, ma'am.
I will share the screen.
Yes,
Is my
ma'am.
screen visible, ma'am?
Yes, ma'am, your screen is visible.
It is showing last slide.
So I will share it. Is it visible now?
Yes, ma'am, it is visible now.
Thank you. A very good morning. A very good morning to one and all present here. I'm Kritika, research scholar at School of Social and Behavioral Sciences, Amrita Vishwa Vidyapeetham, Tamil Nadu. And first of all, I would like to thank the entire conference team, SMARTCOM 2025, for providing me this opportunity to present my work here. I am presenting on the paper Mapping Social Barriers in Indian Plantation Communities, Insights and Recommendations. And this paper is authored by Kritika P. And my research guides are Dr. Suresh M. and Dr. S. Kanagraj. To start with the presentation, this is the outline of my presentation, like introduction and study background, research methodology, study results, conclusions, research implication, future research, and references. Like to start with the introduction, like agriculture is one of the major sector which employs around more than 70% of its rural population, and it provides livelihood opportunities for them either directly or indirectly. In that agriculture sector, plantation sector is one of the predominant sector which plays an important role. Like it employs more than 2 millions of workers in the sector, and plantation sector plays a very crucial role in the export of agricultural products like tea, coffee, rubber, and spices. And we have plantation sectors in our country found majorly in Assam, Kerala, and Tamil Nadu. So major focus of plantation sector will be export, and it will be helping in improving the economy of the country and contributing a share to the GDP. So, despite the economic importance, the plantation workers in the sector face various challenges and issues and barriers which are hindering them to work conveniently or comfortably in the workplace. A study conducted by Perumal in 2021 stated that plantation work is predominantly outdoor based, often set in forested environments, and demands significant physical exertion from workers. So, from this study, we can understand that Indian plantation community workers encounter a variety of challenges which adversely affect their quality of life. The plantation workers are provided with minimal amount of wages. They are not much educated. There is no gender equality among them between men and women who are working in the sector. There are also caste-based discrimination which is prevalent in the sector, and substandard living and working conditions. The workforce in the plantation sector comprises of permanent workers, temporary and daily wage laborers, majority of them having low wages, poor sanitation, insufficient social protection. So additionally, the significant portion of the workers in the plantations remain uneducated and illiterates, reflecting a systematic neglect. This was quoted by Baumik in 2015 and Das and Roy in 2019. And Hazan in 2014 highlights that the workers in the plantation sector have they have problems like social dignity, issues with social dignity. There are also discriminations in the caste, and sometimes the male gender dominates the female gender. There are some sort of violence also prevalent in the society. So the community, the plantation community lives in an unhygienic environment with inadequate basic facilities and medical facilities. Even in emergencies, they feel difficult to approach a hospital and get their treatments. So, because of it, many of the lives are also gone. So, the findings from the study conducted by Raman and et al. 2024 states that thematic clusters such as environmental adaptation, public health, and energy policies, underscoring the importance of solutions, require international conference cooperation for achieving the SDGs effectively. So, from this literature, we found that there is a gap. The gap identified was all these papers have focused on individual barriers separately. So the gap identified by us where the individual barriers have been extensively studied, and there is a lack of comprehensive models that capture the interdependence between the factors and how each factor influences the other factor. So we thought this gap would be studied for better understanding of the barriers. So, coming to the research methodology, the aim of the study was to explore and analyze the social barriers impacting the plantation communities in India. Objectives of the study is to identify the critical barriers impacting the plantation communities in their workplace and to analyze the interrelationship among these barriers and prioritize their impact on plantation workers. And the research question were, what are the barriers impacting the farmers' marketing practices, and how they affect one another. Research design. The research design adopted for this study is decision-making trial and evaluation laboratory, and this method was developed in 1970s by Battle International Institute. And the major advantage of using this study is using this method is we can understand the interrelationship and causal cause and effect relationship between the factors. And many of the researchers like Sai et al. And Vimal et al. Have used these approach and have found the cause and effect factors, and I try to identify the interrelationship among these factors. One of the major benefit of DMATL approaches is that it doesn't depend on the sample size, and it helps in understanding or establishing the causal relationship between the factors or barriers. In this research, we have used the DMATL approach for analyzing the interrelationship among the social barriers that plantation communities face in their workplace. And these are the steps in the DMATL approach: identification of barriers and factors, establishing interconnectedness between the factors, developing influence matrix, constructing the scatter plot, cause effect diagram. So the factors were identified with the help of literature review and expert opinion. Expert opinion in the sense like expert are those who are having good amount of experience in the plantation sector, and they are working in the field. So they were considered for this study. Some of the barriers identified for this study were income, education, social position in the community, social networks, migration, exploitation, and living conditions. And with this identified barriers, the initial direct relationship matrix were calculated. The data were collected using the 5-point scale Likert questionnaire. From that responses, we tabulated the direct relationship matrix. The responses were collected from 10 respondents who are working in the plantation work, and they were selected on their knowledge and experience in the field. With this DRM, we will be calculating the influence matrix. The influence matrix helps us to find the degree of relationship, like how each factor is affecting the other factor, and how the relationship between the factors can be identified, can be understood from this table. And degree of relationship is identified from the influence matrix. From the degree of relationship table, we can rank the barriers, like which barrier has the most influence or which is most impactful barrier faced by the plantation community. So from this table, we can see that barrier 1 is ranked first, barrier 2 is ranked second. Like these two are considered as the most impactful barriers that are faced by the plantation workers. So from this cause effect diagram, it is clearly understood that B2 and B1 are the most impacted barriers
Excuse me,
affecting
ma'am.
the community. Yes, ma'am.
We have exceeded the limit of 7 minutes. I request you to kindly conclude the presentation as soon as possible, please.
Yes, ma'am. Thank you. Thank you. And these are the causal interaction between the factors. Like from the table, it is evident that B1 and B2 are the most influenced factors affecting the plantation workers. Barrier B1, it influences more barriers like barrier to education, social position in the community, migration and living condition. And barrier to education, which ranks next in the influence, also affects a very few barriers like social position in the community, migration and living condition. And to conclude with the presentation, the study highlights that complex relationship between the barriers, and barrier 1 and barrier 2 are the most influencing barriers. And this GMATL approach helps in identifying the interrelationship between the barriers and providing an understanding about how it is impacting. And it concludes that improving income and education access can act as essential drivers to reduce discrimination and enhance the quality of life among the plantation workers. And the findings aim to inform policymakers and other stakeholders if they work collaboratively and create a supportive environment for these workers. It will make them to work more comfortably and conveniently. And these are some of the research implications, like if the plantation workers are provided with some kind of skill trainings or free and subsidized education, they would be more knowledgeable, and they can explore the opportunities available for them, and they will try to come out of their community and seek for a betterment. And they should also be provided with an environment with proper hygienic conditions, especially wash facilities, water, sanitation, and health facilities. And future directions, from in this study, we have identified only 7 barriers. So future studies can identify more number of barriers, and focusing on socio-cultural, environmental, and political factors. And other than the direct interview, more focused group discussion among the workers could pave a way for better results. Conducting longitudinal research can track the evaluation of social barriers and effectiveness of interventions over time. And these are some of the references. Thank you.
So are you using any intelligent method?
Sir,
Are you using any intelligent method?
intelligent method? No, sir.
Okay.
Thank you so much for your presentation, ma'am. Now we'll call
Thank
upon
you.
the next presenter. Our next presenter is Aishani Das, presenting a paper on the title Sentiment Insight Leveraging NLP for Real-Time Feedback Analysis. If you are available with us, I request you to kindly take over with your presentation, please.
Yes, ma'am. My teammate will present.
Okay. Ms. Kritika ma'am, you're still presenting. I request you to kindly stop presenting the Thank you.
1 second.
Request you to kindly switch on your mic, please.
Yes, ma'am. Is it visible?
Yes, ma'am, the PDF is visible and you're audible now. Thank you.
Okay. Good morning, everyone. We are honored to be here today to present our research on sentiment insight leveraging NLP for real-time feedback analysis. I am Oishani Das and I'm presenting this work alongside my co-authors Shreyashi Dey and Shobita Ahila ma'am. Here is a short outline for the upcoming slides. With the rise of e-commerce businesses, heavily rely on reviews to understand consumer opinions and improve their services. However, manually analyzing thousands of reviews is neither practical nor efficient. This is where sentiment analysis plays a crucial role. Our research focuses on developing a robust natural language processing based sentiment analysis model that can classify user feedback. Understanding customer sentiment is essential for businesses to gauge product reception, identify key trends, and refine their offerings. However, the existing sentiment analysis approaches often struggle with large data sets, domain specific language, and ambiguous sentiments. By leveraging machine learning and deep learning techniques, our goal is to build a scalable sentiment classification model that accurately categorizes Amazon food reviews into positive, neutral, or negative sentiments. Um, in the age of digital commerce, online reviews have become a primary source of consumer feedback. Businesses rely on these reviews to gauge customer satisfaction, identify key product features and concerns, and improve their offerings. However, manually analyzing thousands of reviews is impractical. So, this is where sentiment analysis plays a crucial role, enabling businesses to extract insights efficiently and make data driven decisions. So, now why Amazon food reviews? Amazon, being one of the largest e commerce platforms, hosts an extensive repository of customer reviews across various product categories. Food reviews, in particular, offer rich textual data with varying sentiments, making them an ideal dataset for sentiment classification. So, existing research in sentiment analysis has evolved from traditional machine learning models such as naive Bayes, logistic regression, and support vector machines to deep learning techniques. While traditional models provide a solid foundation, they often struggle with contextual sentiment understanding, especially in cases involving sarcasm or informal language. BERT, which is bidirectional encoder representations for transformers. On the other hand, it is designed to capture contextual meanings, making it a powerful tool for sentiment analysis. So, for this study, we utilize the Amazon Fine Food Reviews dataset, which contains a large volume of customer reviews. Our methodology involved several key steps. So, first, we have pre processing the textual data. Here we have included removing stop words, punctuation, and handling the negations to provide consistency. Secondly, feature extraction, which we have done using TF-IDF for traditional models and word embeddings for deep learning approaches. And then training multiple models, including logistic regression, naive Bayes, SVM, and BERT, to compare their effectiveness in the sentiment classification. Then evaluating the models using standard performance metrics such as accuracy, precision, recall, and F1 score. So our experimental results demonstrate that traditional machine learning models performed well, with SVM achieving high accuracy among all of them. However, our fine-tuned BERT model significantly outperformed the classical approaches, achieving an F1 score of 0.9, highlighting its ability to capture complex sentiment structures. While BERT provided superior contextual understanding, misclassifications were observed, particularly in cases of sarcasm, ambiguous phrases, and domain specific terms. Additionally, BERT's computational requirements were significantly higher compared to the traditional models. This trade off between the accuracy and efficiency is an important consideration for businesses implementing sentiment analysis. In conclusion, this research underscores the effectiveness of deep learning models like BERT in sentiment analysis while acknowledging the practicality of traditional models for real time applications. Our findings suggest that hybrid approaches or ensemble models could further enhance performance by leveraging the strengths of both machine learning and deep learning methods. Further improvements shall include fine tuning the BERT model for even better accuracy and efficiency, also expanding the data set and incorporating real time feedback along with multilingual support. So, these enhancements will improve the scalability, making the model adaptable across industries like e commerce and customer support. These are some of the references, the papers that we have referred. We sincerely thank the organizers and reviewers of SmartCom 2025 for this opportunity. We appreciate your time and look forward to any questions you may have.
How is the performance of natural language processing?
Yes, sir.
How is the performance of natural language processing in your case?
Yes, sir. So the performance of the NLP models in the papers is we have evaluated using accuracy, precision, recall, and F1 score. So in the machine learning models for logistic regression, the accuracy was around 82%. For naive Bayes, it was around 79. For SVMs, 85, and for light GBM, it was around 83, 84. So here the SVM is outperforming the other traditional models, achieving the accuracy of 85%. And sir, we have used BERT. So in our case, BERT has achieved the highest accuracy of 90%.
Okay, thank you.
Thank you, sir.
Thank you so much for your presentation. Now we'll call upon the last presenter for this session, Tinoy Santra, presenting paper on the title Solar Powered DC Converter, Fed Electronically Computed, Motor Driven Electrical Bike. If you are available with us, I request you to kindly take over with your presentation, please.
Hello, ma'am. Is my presentation visible?
Yes, sir, it is visible.
So good morning, everyone. My name is Tinoy Santha, and I am excited to present our project on the solar powered DC-DC converter fed electronically commuted motor driven electric bike. This project was undertaken in collaboration with Mr. Ritik Gupta, Mr. Sahil Nikra from VIT Chennai, and guided by Dr. R. Gunabalan. Today, I will walk you through the motivation behind this project, the problem it addresses, the solution we propose, and the results we achieve. Electric vehicles are rapidly transforming the automotive industry due to their environmental and economic benefits. With governments pushing for greener energy solutions, the market for EVs has been exponential growth. However, this sector faces technological challenges that need urgent solutions.
One major challenge is finding renewable and efficient energy sources for these vehicles. Solar energy, being clean and abundant, stands out as a promising solution. In our project, we chose a DC-DC buck boost converter for energy conversion and management. This choice was driven because this converter can either increase the voltage or decrease the voltage as per the solar condition, which is essential when dealing with unpredictable solar energy input. Our solution focuses on powering a BLDC motor used in electric bikes through a solar panel as the energy source. Uh, but couple of problems are there with EVs in major parts of the world, like limited availability of charging points, short driving ranges, and slower speed compared to traditional vehicles, and long charging times. These issues make it difficult for EVs to compete directly with internal combustion engine vehicles. We sought to explore whether integrating solar energy with advanced power electronic devices to extend driving range and reduce dependency on conventional charging stations. So the objective of our research was to design and simulate a DC-DC buck boost converter for electronically converted motor-driven electric bike. In our simulation, we have chosen motor as a BLDC motor, and the simulation environment we have used a MATLAB. So our design, this is our simulation and block diagram where basically the block diagram says that the output from the solar PV is given to a buck boost converter, which take care of the voltage, stable voltage to the inverter, and finally the inverter output is given to the BLDC motor to drive the motor. And from the BLDC motor, the back EMF is taken as the input to the controller, which basically drives the electronic switches of the inverter. And the extra if the output is much higher, then that output voltage can be used to charge the battery, which can be used during emergency conditions when there is not enough solar energy. And these are the converter specifications, and we have calculated LC values from the converter specifications itself. And this is the open loop simulation diagram of our buck boost converter. So this is the open loop simulation. First of all, this is the boost mode. Boost mode means when the output voltage is greater than the input voltage. So we can see that input voltage we have provided 30, and the output voltage we have received as 4.47 volt. And this is the buck mode operation where the output voltage is lesser than the input voltage. So when the input voltage is 60 volt, we have provided, and the output we get as 4.47 volt. And this is the closed loop simulation block diagram of our DC-DC converter. So basically, in the open loop simulation, we don't have any feedback, but in the closed loop simulation, we provide feedbacks to basically to ensure that the output voltage is constant even if the input voltage is changed. So the output voltage the actual output voltage is subtracted from the reference voltage, what is 48 volt, and 48 volt is basically the power voltage rating of the BLDC motor, and the error is given to a PI controller, and the output of the PI controller is then compared with a triangular waveform to generate the PWM signal for the MOSFET or the active switch of this computer. These two are the motor specification and the solar panel specification. We selected a high efficiency BLDC motor, which is widely preferred for EV application due to its lightweight, high power density, and energy efficiency. The motor operates at a rated current of 13.7 ampere and delivers a rated power of 660 watts with a torque constant of 0.11 Newton meter per ampere. On the power generation side, we use a high quality mono PERC solar panel with an open circuit voltage of 81.5 volt and maximum power current of 4.5 ampere. This panel type offers high efficiency and reliable long-term performance, making it suitable for solar vehicle application. We conducted the simulation by connecting our converter closed-loop converter with the BLDC arrangement. So we have a converter, and then the output of the converter is fed to the inverter, and output of the inverter is given to the BLDC motor, which basically drives the bike. And so these are the simulation results. We have tested our circuit in three rated conditions. First is the no load, where there is no load, and under no load condition we observe stable output waveforms with minimal voltage ripples. And this this is the result when we have conducted simulation during rated load condition. So at the rated load of 2.1 nanometer, the system maintained a steady power output, demonstrating efficient energy conversion from solar to electrical power. And there is a peak load condition, which is at 6.3 Newton meter. So at even at peak load condition of 6.3 Newton meter, the converter managed to deliver consistent voltage and current outputs, despite having some ripples in the current, just because of it is due to the tuning of the PI controller. So optimal values of the PI ensures that there will be minimum ripple on the current and voltage waveforms. And adding filters on the output side of the inverter can also on the output side of the converter can also be helpful to reduce the filter to filter out all the ripples and make the current waveform smooth and steady. So in conclusion, our project demonstrates that a solar power DC-DC converter for electronic commutated motor-driven electric bike is a viable and sustainable solution. The benefits include a long driving range and improved speed, zero carbon emission, lower battery maintenance cost, and zero fuel cost, and a reliable solution for petroleum-based vehicles. And I believe that this innovation can make a significant contribution towards reducing our reliance on fossil fuels and advancing the future of clear transportation. These are some of the references that we referred for our research for this paper. And thank you for your attention, and thank you SMARTCOM for giving us the opportunity to present our paper and research work, and I would be happy to take any questions. Thank you.
Dr. Vishwajit Thakur, sir, do we have any questions for him?
No, that's fine. Thank you.
Okay, sir. So now we'll come to the end of our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this ninth version and all the other previous 8 versions of this conference. We will be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificate through their email within 2 working days. Further, all the papers have already been forwarded to the Springers. Thus, publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. Just a second. I also thank our session chair for chairing the session. A token of appreciation to the chair on behalf of the team of SMARTCOM 2025 and Global Knowledge Research Foundation and partners. Thank you so much, sir, for your valuable presence. Would you
Thank
like
you.
to? Thank you so much, sir. I request all of you all to kindly switch on your cameras for a quick snapshot of this virtual conference. Thank you so much. Now we'll be closing the session. You all can log out and see you in the next year, 2026. Thank you so much.
Yeah, Prashi,
Yes, sir?
can you just send that certificate you showed to me by email?
For sure, sir. For
Okay.
sure. Thank you. Thank you, sir.